As you think about that here, we're looking ahead. Next week is when we will kind of begin a lot of different quizzes over the next few weeks, right? We are going to spend a lot of time early in the week here going over new stuff, finishing up kind of some stuff here in chapter 7. Then we're going to go back into the packets, probably start a new one this week as we head towards the finals, which the first one will be next Friday. So, week from this Friday. So, we won't take a quiz over chapter 7 right away after we finish it. Now, it's a little bit unusual to do it that way, but it's going to work out fine. But also because we're at that point where I want us to be able to tie in all these different things. And so, we'll have a chance to review before. Right now, that's scheduled for next Wednesday. Okay, our quiz over the chapter 7 stuff. Okay, and we're going to be adding to that this week. Okay, and then a chance to kind of digest that, but also go back and reviewing other stuff. And so next Wednesday quiz. Now we have short periods Monday through Thursday, right? Because they have the NISA testing. They have the math and NISA testing. You guys, seniors don't have to be here, right? It's like a late start all next week. Well, Monday through. At one point, I think they said seniors were going to have to come.
Yeah, we don't have to be here anymore.
So we're not. So like this Wednesday's a shorter day because we have the teacher work day. Everybody has a late start. But then Monday through Thursday this week, late start, which means a class about an hour long. But that would be enough time for a quiz. Okay, so that's going to be on Wednesday. So next Wednesday is going to be our quiz on chapter 7. Next Friday will be our first final. Then we'll probably go Tuesday, Thursday of the next week finals. That's kind of what I'm thinking right now. So Friday, next Friday, not this coming Friday, but the one after, and then the next Tuesday, Thursday, and then the next Tuesday, I believe. And I think the AP test, that takes us right up to the AP test. I think the AP Calc test is on that Wednesday, which is like the what, 4th?
Tuesday and then Thursday after Friday.
Tuesday and Thursday. So Friday's the 22nd, Tuesday and Thursday's the 26th, 28th, and then that next Tuesday, either that next Monday or Tuesday, I'm not sure, like May 2nd or 3rd. AP Calc test is on the 4th, and then of course your last day is that next week. Okay, so that's kind of how. So that gives us kind of a day in between where we can maybe you can get it back, you can kind of see what you missed. And maybe that helps you a little bit on the next section or whatever. But also as we get towards the last couple, we'll be starting kind of the process of our last couple kind of group assignments. You'll be able to start working on those a little bit too.
Get our grades back up.
Maybe. I don't know. All right. So, anything we want to yes. 51B. Now again, like I think I was telling you, I think the pictures that they draw are almost more confusing. Now in 51, I'm not sure they drew a picture, did they? So that's actually fine. Okay, so at 51, it says, 51, is that what you said? The base of a solid is bounded by y equals x cubed, y equals 0, and x equals 1. Find the volume of the solid for the following cross sections that are taken perpendicular to the y-axis. Okay? And so, and now it's perpendicular to the y-axis, so that would be horizontal slices, right? Horizontal strips. So we got y equals x cubed, which would come up something like so, and over here as well. And it said y equals 0, which is the x-axis, and x equals 1. So x equals 1 is over here. Okay, here's the x-axis. So we're talking about this region right in here. And and that's 1, and this is y equals x cubed, and this would be the 0.11. So you've got to find those intersection points. So this quiz will be all calculator. You'll be able to graph them and so forth. But we're supposed to, this is a base of a solid, so coming up off of this page are going to be slices. So in other words, and it's not very good three-dimensional, but coming up off of the paper here will be semicircles, right? Like so. If you wanted to, if you wanted to try to lay that, I like trying to do this sometimes. It doesn't work out real well always, but if you wanted to kind of lay that flat, it might look something like that. There'd be my y-axis. There'd be this x cubed coming up like so. Here would be a semicircle. Oops. Little tiny spot. That's really good, right? Kind of a cone kind of shape, kind of. We kind of had one of those in this drawing. That's really a lot like. The difference is this was just a line, but this was be very much like that situation right there that we had. Okay, except this is a line rather than a curve here. But anyway, this strip. So this strip is what? Part of that semicircle. It's the diameter. So if I was writing off to the side here, I would say D equals, and this strip, I need this right x coordinate. What is this right x coordinate? 1 minus this left x coordinate. It's x equals the cube root of y. See, that's, again, listen to what I was saying. I was saying this right x coordinate minus the left x coordinate, right? And so this needs to be x equals, because I'm looking for the x coordinate, so I need to know what x is. So it's going to be x equals. So cube root of y, which we would write y to the 1/3. So this is y, 1 minus y to the 1/3. That is this strip, and that strip is the diameter of a slice. So semicircle slices have a 1/8 pi times the diameter squared, right, was the formula we had for that. And then dy would be the thickness, so it's area times thickness gives us volume. And these strips will fill the space from 0 to 1. Hard to miss that one because it's 1 either way, even if you go the wrong way. Okay, so there it is. Type that in your calculator, get your answer. Okay, remember, horizontal strips, you have to get x equals. Vertical strips, you write the equations as y. Okay, again, these are the equations you have to be responsible for. All right. Anything else? I want to look at one. I just thought of this, so I need to. Did we talk about this one? I know I did in the other class. I can't remember if I did in this class. This is 2009, so this is not a packet you guys have. Here's a region. You're given just two simple little a line and a parabola. The region R is the base of a solid. For this solid, at each x, the cross section perpendicular to the x-axis, so that would be vertical, has the area of this. Find the volume of the solid. What are you going to do? What's different about this one? They didn't tell us the shape. So is that good? That bad? What? Keep going. So what do I do? What's our integral formula? What goes inside the integral? The area of a slice. Isn't that what they gave us? Yeah. In other words, it's pretty easy. I'd never seen this before in the AP test. I'd never done one like this, and I remember when that one came out, like, oh, that's interesting. They're trying to see if you're just memorizing about slices and stuff like that, memorizing formulas, or do you really understand what it is you're doing, right? What are you putting into the integral? You're putting in the area of a slice. They gave you the area of a slice. So it's simply that from, and then you had to know, since they're vertical, it would go from 0 to what? That was it. Right? And now this might have been a no calculator one, I think. So you've got a little bit, you're going to have to do the antiderivative of sine, which would be negative cosine, and you leave this alone, but you have to kick out a what? No, you're doing antiderivative. So you have to kick out that, right? And then it would be from 0 to 2. So now when you put a 2 in here, that would cancel that 2 to be cosine of pi. Cosine of pi is negative 1, which would be 1. Positive 1 times 2 over pi, so that'd be 2 over pi. Minus, now put in a 0, cosine of 0 is 1 times negative, that's negative 1 times that, that'd be negative 2 over pi. So it'd be 2 over pi plus 2 over pi, which is 4 pi, 4 over pi, right? 2 over pi plus 2 over pi would be 4 over pi. So you would get, you would just have that right there. So I think that was a no calculator one. And then here it says write but do not evaluate, so you just had to set it up. But anyway, the idea is when we find the volume of a solid, what we're looking for is an integral, and we want to put the area of the slices. They told you the area of the slice. They didn't tell you what the slices were. They just told you that the area of the slice, what it was. And so that should be even easier. We just put it right in. Okay, there was another one here. I don't remember. I think it's one we didn't have. That wasn't it. Might have been 2011. No. Maybe it was 2012. Oh, don't. Too many things open. All right, let's go. Might have been 2012. No.
Write it out. That's what we're doing.
I hate that. My dad will like watch a movie and just sit down. I said I was gonna leave in 5 minutes.
All right. Well, I can't find it right off the top of my head, but I'll just tell you what it was about. So it looks something like this. Back up here. Okay, so let's say we had some region, okay, like so, whatever, and this region, and what it would say is that the slices, so this was the base of a solid, and the slices perpendicular to the x-axis, so that would be like so, okay, like this. The slices coming up off of that base were rectangles of height 1. Was that in was that one we had to do?
Yeah.
Did we do that one? Yeah, and I know I've seen it in the AP test too. Coming up off of here are rectangles of height 1. Well, the problem with a rectangle area, what is the area of a rectangle? Base times height, right? That's 2 variables. But since they told me the height is 1, it's just the area of the rectangle is just b, whatever the base is. And what's the base of these rectangles? It's that strip, right? This strip is the base. Like coming up here would be rectangles. It'd be like rectangles coming up off of there. But if they said height 4, right? Rectangles of height 4. Well, it'd be b times 4, it'd be 4b, right? 4 times whatever the strip is. So we do top minus bottom. That would be, and then take that times 4, and that would be your area, right? So there could be some. I don't anticipate that on our quiz, but that's one that I've sometimes seen. Okay. Another one I've sometimes seen is the rectangle, or coming up off the slices are isosceles right triangles. Isosceles right triangles coming up off of the page, where one of the legs is on the base. So in other words, this is one of the legs of an isosceles right triangle. So that means in your region, if you laid this down, I always do that. If you lay this down flat, here's your region coming up off of there. That's one leg. Here's the other leg like that. And that's a right angle. And then it's like a triangle. Well, what's the area of a triangle? 1/2 base times height. Well, this is the base and this is a height, but since it's isosceles, they're the same, right? So this would be 1/2 b squared, where this would be the b, right? That'd be the base. This would be the base of your triangle, and then coming up off of the base is the other leg. Well, they're the same, so it'd be 1/2 b squared. So the strip, whatever the strip is, would be the b, right? So that's another one that I've sometimes seen, isosceles right triangle. Okay, no matter what, somehow the strip has to be one part of that shape that you need it and it alone to do the area of whatever that shape is. So those are some other kind of possibilities. Okay, let's do one that we're going to add into our notes. So this is kind of what you had before, so I don't know if you want to throw that in, but let's do this problem right here. So draw yourself a little picture of this. We're going to do this with methods we know right now, okay, with our slicing method. We're going to do this. We're going to revolve it about the line x equals 5. Okay, so draw that. Get your calculator out if you have to. I hope you don't have to for square root of x, but if you do, you'll have it. So draw that region. Okay, draw that region, revolve it about the line x equals 5. And set up that integral. What are some things going on in this problem? I mean, it's just a basic revolving a solid, right? It's got to either be circle or donut, washer, slices, right? So what's going on? What do you got? Okay, it's got to either be circle or donut slices. Which one is it?
Donut slices.
Okay, there's empty space, so it's got to be donut slices. What else is going on? So it'd be horizontal strips, right? Okay, what else is going on? You got to split it. You got to split it into 2 parts, right? Why? Horizontal strip down here will hit the region over here on this line. Horizontal strip up here will hit the curve right here. Got to split it. to split it. Okay? So we got to split it right there where the red line is. So your outer radius, now remember, here is your axis of revolution. That's your center. Radius always comes from the center. So here's big R, and here is little r. Right? Big R and little r. Down here, big R is there. And little r is the same. Okay? So remember, the formula is pi, which we usually pull out in front. A lot of those formulas we can do. They have the root 3/4. You can pull that out in front. 1/2 or the 1/8 pi you can pull out in front of the semicircle one. Pi r squared, you can pull a pi out in front, but it's big R squared minus little r squared. Right? So in their horizontal strips, you got to get x equals, so it'd be x equals y squared, so it'd be 5 minus y squared, 5 minus 4. That inner radius is just a constant. And then on the other one, actually this bottom piece would just be a cylinder, wouldn't it? When it revolves around, it's got a constant outer radius, a constant inner radius, so it's got 4 and 1 as its, okay? And then what would this, the top integral go from? What to what?
1 to 2.
This piece, the strips go from 1 up to 2, and then this one would be 0 to 1. Okay? Type that in, let's see what we get, because we're going to learn another way we could do this one. Is the new thing we're going to do today, and we'll compare our answers.
So there's an easier way to do this.
Yes. 300 what?
28 pi over 50.
Anybody else agree with that?
5
No? That's what you got? How do I do it? Type this one. Well, we'll do it the new way, and we'll see if we're going to see what we get. Rachel, you got this.
That's what I got too.
Okay. All right. Now, that would look, well, doesn't matter what that would look like. confused. So now, in your notes, so here's a region. This is where we started with these revolving type of regions. Now, this new thing we're going to learn is an alternate method. If you go to this little table that I have here in my notes, it's an alternate method for volumes of revolution. For volumes on a base, that's it. That's the only way to do it, right? Add up the slices. Add up the slices. For volumes of revolution, for a region that's revolving, we're going to have an alternate version. Okay? And this is going to be called the shell method. Okay? The shell method. And this is an alternate to slicing. Okay? Instead of adding up slices. Sometimes I call the shell method layers. What we're going to do is we're going to think of adding up layers instead. Think of an onion. Right? With its layers. Right? You could peel off a layer and and keep going. Kind of with the lemon, if we would have had a way. I was thinking last night you guys have one of an apple core, one of those round things where you can just set an apple down, you slice it right through, and it cuts it into slices and takes out the core. There's a little round piece in the middle. So you end up with this little cylinder piece of apple left where the core was. It just comes out. Well, if you had one of those where it had a bunch of concentric rings around it, right? You took an apple and it just went like that. You'd have these cylinder-shaped slices of apple. If they don't, I don't think make such a thing. That's kind of what it is, but think of it like the layers of an onion or something like that, where if we found the volume of these cylindrical wraps or these cylindrical layers and it had the integral, add those up, that would also give us the volume. Okay? And so that's an alternate method to slicing for volumes of revolution. Okay? Now, what does that look like? Well, if we go back to this, okay, here if we took this region and revolved it, and we're looking at slices, here the slices would be washers, and we added those up, right? We added all those up, right? That's what we just got to do. Now, ours was different. We have horizontal slices, so it's a little different deal than that. Okay, and it was kind of like doing this. It was kind of like if you think about the lemon, okay, if you think about the lemon, we were doing it this way. We had like 6 slices, so they were kind of thick. But we said eventually we were going to do how many slices? What's the integral do? Infinite number of slices. So they were really, really thin. And at that point, that was the dx or the dy part. But really what we were doing was adding up, right, all these slices. Now, it wasn't exact. Remember, that's because we got this little these pieces here. That's where we had to do that averaging thing to kind of make it work out, right? But if you have an infinite number of them, you wouldn't have to do that, right? You wouldn't have that issue. Okay, well, that's slicing. But this is kind of like the problem we just did. If I was going to take and revolve this pink region, okay, there's what I mean by one layer of the region. If I show the other half of the region, right, this would be okay, that would have some volume to it, right? Sometimes this is called the method of cylindrical shells, okay, or cylindrical layers. That's a cylinder, okay, and this would get, as this rectangle gets narrower and narrower, then this would get, right, this would be our dx piece right here, this width right up here, okay, and if we add up all of those, right, now that's only like 6 of them, but if we had an infinite number of them, okay, we could kind of see this. And so here would be, here we go. So if I would look at this, right, in the black in there, kind of in between, would be one of the shells. Okay, and the integral would be, so what we're doing is we're saying let's add up let's have the integral, let's find the volume of one of those shells, and let's let the integral add that up. Okay, so that's the idea. Now, what's the advantage? Notice what direction the strip is. Where's the axis of revolution here? What direction is the axis of revolution? And so is it vertical or horizontal? No, the axis of revolution, not the y-axis, right here. Okay? It's vertical. What direction is the strip? How did that work with disc washers? What direction would it have been? It's perpendicular to, right? If you've got the axis of revolution here, when you do a slicing, it's got to be perpendicular to the axis of revolution, right? What we're saying is with wrapping, with shells, with layers, the strip can be parallel to the axis of revolution. Well, what advantage is that? It's a great advantage. Because in this problem, remember when we had to split it right here? Because we had to do horizontal strips. We were forced to do horizontal strips since our axis of revolution was this way. We were forced to do these. This method, they're the reverse of that. So we can do vertical strips. So if you get a problem where horizontal strips would be hard, this method would have vertical strips. And vertical strips should be easy. Because look at these vertical strips. They fill the space. They touch the same curve on top and the bottom the whole time. So this idea, instead of slicing this way, we're talking about wrapping this way. Or if we were like this, we'd be slicing this way, but we'd be wrapping this way. Okay? So because the strips switch direction as far as instead of horizontal to vertical, it can be an easier way in some problems. So it's an alternate version. Now, in your homework, there's going to be some that's going to, it's going to say they want you to do them with shells. So we're going to do that. On the quiz, I may say do this one with disc washer, and I may say do disc washer means if there's empty space, it's washer. No empty space, it's disc. So that's what I mean by disc washer. Or, which is a slicing, basically. Or I may say do this one with shells. Or I may just give you one and say, hey, just do it, and you can do it either way. Maybe one way will be easier than the other. Okay? All right. So let's take a look. So it's essentially this. Okay? So you have a vertical axis of revolution. If we were going to be doing a washer or a disc situation, here's this empty space, right? So this one would be a washer. It would look like that. They'd have to be horizontal strips. But if we do the shell method, they would be vertical strips. So that's the difference between slices and layers. And so we'll have layers inside layers. So our job right now to come up with this formula, our job is to say what is the volume of this. Okay? Now, what was the volume of this? We did the area of this times the thickness, right? And that gave us our dx, and that gave us our volume. We need to do the volume of this. Okay? All right, so that's the next thing we're going to do in our notes. Okay? So, there we go. So, draw yourself, it'll be hard for you to draw it as good as mine, probably, but draw yourself a cylindrical shell. Okay? So, there's empty space in here, right? There's empty space in there. Now, we don't have to care about that empty space. I mean, we do in the sense that we're doing the volume of the solid. So, we're doing the volume of this cylindrical shell. So, what would be the volume? Just in general, of a cylinder, and then this little shaded thing I have down the side is like that rectangle that created this. Okay, that's this red. If I keep that going, see if I can stop it. Perfect. Okay, that's this red rectangle. That's the part that's going to get thinner and thinner and thinner, right? This piece right up here is the delta X part. Right up here. Okay? That's the part that's going to get thinner and thinner and thinner. All right, so in my picture, what would just normally be the volume of something? What's the volume of a cylinder? What's the volume of a cylinder? Pi r squared times the height. So here's the height right here. Pi r squared. But now what we have, but how do we find the volume of this solid? It's kind of like the washer problem, actually, isn't it? What would be the volume of the solid piece? The solid cylinder. you'd have to subtract it, right? Yeah, so it'd be pi big R squared H minus pi little r squared H, right? We have to take the outer cylinder minus the inner cylinder, and that would give us the volume of the solid. Now the problem is I don't have my dx in there. I need to get my dx in there. That's this length right here. Okay, let's call that W instead of delta X. Well, what the heck? Let's call it delta X. That's what it is. Let's call it delta X. Okay, that's our delta X. That's the part that's going to go to basically nothing and end up being a D. I need to get that involved here. But is that in here anywhere? Is that any of these things? It's definitely not the H, and it's definitely not the big R or the little r, is it? It's the W's the difference between them, isn't it? Okay, so here's what I'm going to do. I'm going to, this is going to get a little bit technical, but you're going to, you're going to wonder why is he doing this, but you'll see here in a second. We're going to call this distance out to here P, to the middle of that rectangle. So P is going to be the distance from here to the middle of that strip. P is going to be the distance from the center to the middle of that strip. Okay, let me write that down up here. P is the distance from the center, which is the axis of revolution, to the strip. Technically the middle of the strip, but once that strip goes down to nothing width, right, it's going to be basically from the center to the strip. Okay? All right. But now, right now, it does have some width, right? It's called delta X. So what would be the big R right now? Using P and delta X. What would big R be? P plus half delta X. Right? And what would little r be? P minus half delta X. Now remember, the delta X is going to kind of go away, but I need to get it in there because it's going to become my dx, and I need that when I do my integral. I need to get that thing that is shrinking, I need to get that in there. We did that when we were doing arc length. We had that dx squared plus dy squared equal the strip, square root of that. We had to get that dx in there so it would be part of my integral. So I'm going to substitute those into here now. So I get pi P plus half delta X quantity squared times H minus pi quantity P minus half delta X quantity squared times H. So I got that. Right? Now, I'm going to need to FOIL that. Now, right now, the pi and the H are bothering me. I'm just going to get those out of the way. I'm going to factor those out. So I got pi and H. Okay? So I'm going to factor out a pi and an H, get those out of there. And now I'm going to FOIL this. So what would this be FOILed? That'd be P squared. Now, what about this? This is P plus half delta X times P plus half delta X. So my outers would be half P delta X, and the inners would be half P delta X. So that'd just be P delta X, right? So plus P delta X. And then I got to square this. So that'd be 1/4 delta X squared. Now, I'm going to FOIL this one and then minus. So I got to make sure that I'll distribute that, right? So it'll be a minus P squared, right? And now when I FOIL this, that'd be what? That'd be a negative half P delta X and a negative half P delta X. So what's that? Would it? Well, it'd be minus P delta X, but then I got this negative here. So I'd have to distribute it, so it'd end up being a plus P delta X. And then what about this? I'd have negative half delta x times negative half delta x. That'd be a positive 1/4 delta x squared. But then I got that negative to distribute. So it'd be a minus 1/4 delta x squared. Correct? All right, what happens to all that? Pi times h, and what do I end up with in there? Cancel, 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 cancel. What is it? 2p delta x. That's nice. So the volume of this shell is that. That's one shell. So let's rearrange it. It'd be 2 pi p h delta x. Beautiful. But that's just one shell. So how could I add up all the shells? Do the integral. Right? Do the integral of 2 pi ph. And then what happens to the delta x when they become real thin? Just becomes the dx from A to B. There you go. Now, what is P and what is H? Well, we got it right here. H is the height of our strip. So that's the same old thing we've been doing, right? H is just top minus bottom. Or if we're going to do this way, we might wrap this way. Maybe we'll do horizontal. Okay, we might have some of the homework where they say you have to do this shell method. So you might have some that are horizontal. So H would be the link to be right minus left. So the H is the thing we've been doing. Top minus bottom, right minus left, the strip, whatever it is. P is the one that's a little bit tricky, but it's actually very easy. We make it way harder than it is. P is just the distance from the center to the strip. Now, what that is a horizontal, right? If you have a horizontal strip, then the distance from the center to there is vertical. If you have a vertical strip, the distance from the center to the strip is horizontal. So what you end up doing in a shell problem is you end up doing both top minus bottom, and you end up doing a right minus left, because the top minus bottom will be the H, and the right minus left will be the P. Okay? And we'll do an example, and then the 2 pi is just in there. So let's do the problem we just got done doing. So let's take this problem right here. So maybe redraw it real quick. We're revolving around x equals 5. But that means, since we're going to do the shell method, we get to have a vertical strip. Now, you might also be thinking, well, what about empty space? Because this problem was a washer. If we do slices, we got to think, is there empty space? So there'll be a disc. It could be just a circle slice like pi r squared, or it could be a washer slice like pi times big R squared minus little r squared. Right? Do we have to worry about that with shell? Well, as you'll see here, it turns out we don't. Turns out we don't. Okay, shell will handle both of those situations. Okay? All right, so the formula is 2 pi p h dx from A to B. So what is h? Let's do h first because that's easiest. H is the height, or I don't even like using the word height. I'm going to say length, because when it's horizontal, it doesn't feel like a height. H is the length of strip every time. That's what H is. Go back to our little picture here. H is the length of the strip, right, that is creating the layers, that's wrapping around. So H is the length of the strip. P is distance or length from center to the strip. Okay, very important that you understand those two concepts right there. H is the length of the strip, which is a normal thing we've been doing, and P is the distance from the center to the strip. So, what is H in this problem? Square root of x minus 0. That is h. All right? What is p? Let me, no, not 5 minus 1. You're close. No. It's going to change because the strip might be here, or here, or here, or here, or here. But you're right. It is 5 minus. What if the strip was sitting here at 2? How far is it from the center? 3. 5 minus 2. What if the strip was sitting here at 3? 5 minus 3 is 2, right? I heard somebody say it. So what is our p? 5 minus x. 5 minus x. In other words, all we do with our strip is we label it x. Now, why do we label it x? Because it's setting on the x-axis. So it's going to have some x coordinate. Might be 1.1, might be 1.4, might be 2, might be 2.3, right? Whatever. So we just label it x, and you can draw it. You don't have to, but this would be p right here. Remember I said p will go the opposite direction of h? So if h is vertical, this is p. P is always from the center to the strip. The strip, we don't know where it is. It's x. Now, what if you had horizontal strips? What would you call the strip? Y. And then it'd be top minus bottom. Okay? The p will always, if we go back to our notes here, p will always be things like this. 5 minus x, 2 minus y minus 1, x minus 0, 6 minus y, something like that. It'll never have a y squared or squared. It'll never have that. It'll always be just x or just y, and it'll always look like that. It'll always look. Now I'm going to tell you that multiple times, and then on the quiz, somebody's going to have p being square root of sine x or something bizarre. But p is always going to be 5 minus x, 2 minus y, y minus 1, whatever, x minus 0, y minus 0, whatever. Always, always, always. Okay? That's what it's going to be. The h is what's going to involve your function. Okay? It's going to have your square root, whatever the case may be. So in this one, it's 5 minus x. That's what p is. Because it's how far the strip is away. Okay? It's this length right here. Okay? Which got involved with our big R and our little r. Okay? When we did that. Okay? As this shrinks down, your big R and little r become the same thing. Right? And so P is kind of like that radius in a sense there. All right. So our integral becomes 2 pi, usually put out in front. P, which is 5 minus x, times h, which is square root of x, dx. And then this is always the interesting part right here. The integral goes from what to what? 1 to 4 or 1 to 5? What have I always said when you're trying to figure out this? Strips fill the space. So what do you think it is? It's 1 to 4. It's 1 to 4. See how that takes care of the empty space? What if this was an empty space? Then it would have been 1 to 5. If we were revolving around here and we were going ahead and including this, then we'd have done 1 to 5. But by going 1 to 4, we don't count that empty space. The empty space from 4 to 5. So we go from 1 to 4. Type it in. Now, that took us a while to do because we're just learning it. But you can see once you had the hang of this, wouldn't that be way easier than the way we did it before? 328 pi over 15, I hope. If not, we didn't do it right the last time. Okay? So that would definitely be one where you would say, and remember, we had this when we had area, where if you want to do the area of a region, you could fill the space with horizontal strips, or you could fill the space with vertical strips. Sometimes they were both easy. Sometimes one was way easier than the other. So you could kind of take your pick. Which would you rather do? And sometimes we did problems where we did it both ways, just to kind of practice both. Well, it's kind of the same way here. Here would be a problem. You guys did plenty of problems in the homework that were pretty easy just by doing slicing. But here's one all of a sudden that we had to split it into 2 parts. it had big R, little r, and had empty space. We had all this stuff, and we had to do that. With this new method, this layering method, we're still saying, hey, to find the volume, we can add up the pieces of it. It's just instead of slicing it, we're adding up layers around it. Okay? All right. So instead of slicing the onion, we're peeling, you might say, the onion. Okay? All right. So let's try this one. Let's practice this one right here. Okay, so when you draw that region, does this one look, I mean, think about it if you were going to do disc washer. What would happen? What direction would the strips be? Horizontal. Would you have to split it into parts again?
Yeah.
Right. Oops. Come on. Wouldn't it be that region right there? If you did horizontal strips, you'd have a problem right here, wouldn't you? These strips would be different than these strips down here. So, this would be a great one to be able to use vertical strips on. You have no choice with disc washer. They got to be perpendicular to the axis of revolution. Shell, they're parallel to the axis of revolution. So what is the H? X squared plus 1 minus 0. And the P? 2 minus X. Right? The P is the distance from the axis of revolution. Now, if the axis of revolution would have been the y-axis, then that's different. Then you'd have had x minus 0, right? If the axis of revolution would have been right here on the y-axis, then the distance would have been from here to here. So it would have been right minus left, x minus 0, right? But the center is over here. So 2 minus x. It's always from the center, from the axis of revolution. Okay, so 2 pi times P times H. Of course, it doesn't matter what order you do the P and the H. And the strips fill the space from 0 to 1. Very, very slick and easy. Okay? Just have to remember the formula 2 pi times P times H. Okay? Let's try one with horizontal. Last one, and then we'll I'll give you the assignment, you can start working. Okay, let's try this one. This is one I think we did earlier when we were learning about dishwasher. But this time I want you to do it with Shell. Wouldn't we be looking at something like this here? Is that what you got? What thing? Are we gonna what?
Are we gonna get back in?
Yeah.
What is that bell for?
Must be the fire alarm.
Hey,
Okay, we go out by the weight room. I don't think this was a planned one. We go out by the weight room, okay?
you must run this school, Clark.
Why is
You're always
that?
the last one out and the first one in. Ooh, alright. Let's pause and see what's here.
Sorry. I don't know if I wrote it down yet. Oh, I have it on my calculator.
All right.
Yeah, me too.
What was it?
224 pi over 15. Always have
224 pi over 15. Now,
Or 224.
okay, couple of things. Since the axis of revolution is horizontal, wrapping shells, layers, whatever you want to call it, shell method is kind of the traditional name. Those strips have to be parallel. The strips are parallel when we're doing shell. So they'd be horizontal. So maybe you wouldn't have chosen this. If you'd have had a choice on this problem, you may not have chosen shell. On our homework, you're supposed to do them by shell for practice. Okay, so that means horizontal strips, which means I got to have x equals. So I got to solve this for x. Okay, the h is going to be right minus left. 2 minus square root of y. The strip would just be labeled y because it's at 1 or at 2 or at 3 or whatever. And then from the center to the strip would be 4 minus y. 4 minus y. Now, it's not always 4 minus y. Sometimes it's y minus 4 or something like that. But it's just top minus bottom, right minus left. And then the strips fill the space from 0 to 4. Now, you may very well, when we did this one a while back, we would have done this as a washer problem. There's all this empty space. So we'd have had big R would have went down to here, and little r would have went right to there, right? And we'd have had 4 minus 0 for our big R, and we'd have had 4 minus x squared, right? Because that's a y value, top y minus bottom y. It'd been 4 minus x squared would have been our big R. So little r would have been 4 minus, big R would have been 4 minus x squared. No, 4 minus 0. Little r would have been 4 minus x squared. And we'd have just set that up, and then the strips there would have went from 0 to 2. So if you want to check that, pi big R squared minus little r squared from 0 to 2, that would have been your washer. And if you type that in, that should give you the same thing. So it's good to practice on the homework, practice some of those by that other method, but you do want to do them all with shell. So on the homework sheet, think the assignment page is the LH page 427. It's down there a little ways. So LH page 427, it's 4, 9, 12, 17, and 21. I think I recorded all throughout the file. So, that's okay, they can fast forward. All right, so there you go. You can get started on those, and that's the LH ones. But I think you should do them all by the shell method. It's not a bad idea on some of them if you can easily check them with the disc or washer. Remember, back to the notes, I guess it would be worth putting that up here, and we can fill that in next time. But basically, the volume is the integral. You kind of already put it in your notes, but 2 pi p times h dx. And sometimes that's called p of x, h of x, because they typically are functions. And it could be dx or dy, depending. Okay? And then what p is and what h is, kind of thing. But this is just an alternate method of doing volumes of revolution. You'll never do shell on a base problem, base of a solid. Those are always slices. Only in the revolving ones is that even an option. Okay? And they say on the AP test most of the time they're done with dishwasher. Very rarely is there one that shells. But sometimes there are ones where a shell could be easier. So, we do it.